Hello everyone, I'm Angela and today we're going to talk about mathematics. Oh yes, how boring. Well, we're going to talk through mathematical wars today. The calculus controversy. So firstly, calculus. What's calculus? Calculus is a mathematical study of change that is fundamental in mathematics, physics, economics, and many other subjects. You'll first encounter calculus in around year 10 in high school, where you first learn about limits, rates of change, etc. And then you'll move on to differential calculus and integration in high school, and then multivariable calculus, etc. in uni. Learning about calculus is when you get into the real maths in high school. Now, we know calculus is super important and is a significant discovery, but there's more. The mathematics scandal relating to calculus is even more eye-catching, as it involves two famous mathematicians. Drum roll, please. The guy who sat beneath the apple tree, Isaac Newton, and the German polymath Gottfried von Leibniz. You may think, oh yes, these two gentlemen must have worked with something together and then got accredited together. Well, you're too naive. The calculus controversy was an argument between Newton and Leibniz over who invented calculus first. The question was a major intellectual controversy which began simmering in 1699 and broke out in full force in 1711. Leibniz had published his work first, but Newton's supporters accused Leibniz of plagiarizing Newton's unpublished ideas. In the 17th century, as at the present time, the question of scientific priority was of great importance to scientists. However, during this period, scientific journals had just begun to appear, and the generally accepted mechanism for fixing priority by publishing information about the discovery had not yet been formed. Among the methods used by scientists were anagrams, sealed envelopes placed in a safe place, correspondence with other scientists, or a private message. A letter to the founder of the French Academy of Sciences or to the secretary of the Royal Society of London had practically the status of a published article. The discoverer could time-stamp the moment of his discovery and prove that he knew of it at the point the letter was sealed and had not copied it from anything subsequently published. Nevertheless, where an idea was subsequently published in conjunction with its use in a particular valuable context, this might take priority over an earlier discoverer's work, which had no obvious application. Further, a mathematician's claim could be undermined by counterclaims that he had not truly invented an idea but merely improved on someone else's idea, an improvement that required little skill and was based on facts that were already known. Back to the calculus controversy. Newton claimed to have begun working on a form of calculus which he called the method of fluxions and fluents in 1666 at the age of 23. Quite young, right? But did not publish it except as a minor annotation in the back of one of his publications decades later. Much of the ensuing controversy resulted from the fact that Newton did not publish this work until decades later. Leibniz began working on his version of the calculus in 1674. In 1684, he published his first paper on differential calculus and then published his explanation of the integral calculus in 1686. On a visit to London in 1676, Leibniz was reportedly shown at least one unpublished manuscript by Newton. This was later claimed by Newton and his supporters that Leibniz had merely invented an alternative notation for the ideas that were first developed by Newton. The prevailing opinion in the 18th century was against Leibniz in Britain, not in the German-speaking world. Claims and counterclaims of plagiarism escalated the dispute, and in the years before Leibniz's death in 1716, he was embroiled in a bitter defense of his work. While Leibniz admitted to being shown the early work of Newton, his private papers demonstrate that his development of the calculus was quite different from the approach taken by Newton. The claim that Leibniz invented the calculus independent of Newton rests on the basis that, firstly, he published a description of his method some years before Newton printed anything on fluxion. Secondly, always alluded to the discovery as being his own invention. This statement went unchallenged for some years. Thirdly, enjoyed the strong presumption that he acted in good faith. And fourthly, demonstrated in his private papers his development of the ideas of calculus in a manner independent of the path taken by Newton. According to Leibniz's detractors, the fact that Leibniz came when unchallenged for some years is immaterial. To rebut this case, it is sufficient to show that he saw some of Newton's papers on the subject in or before 1675, or at least 1677, and obtained the fundamental ideas of the calculus from those papers. No attempt was made to rebut point 4, which is he developed the ideas of calculus in a manner independent of the path taken by Newton. Though this was not known at the time, it provides the strongest evidence that Leibniz came to the calculus independently from Newton. This evidence, however, is still questionable based on the discovery in the inquest and after, that Leibniz both backdated and changed fundamentals of his original notes, not only in his intellectual conflict, but in several others. He also published anonymous slanders of Newton regarding their controversy, which he tried, initially, to claim he wasn't the author of. If good faith is nevertheless assumed, however, Leibniz's notes as presented it to the inquest came first to integration, which he saw as a generalization of summation of infinite series, whereas Newton began from derivatives. So nowadays, derivatives and integrations are kind of on the opposite sides, where we have derivatives and antiderivatives, which is called integration. With the anti-name here, you can see they are quite different. However, to view the development of calculus as entirely independent between the work of Newton and Leibniz misses the point that both had some knowledge of the method of the other. Though Newton did develop most fundamentals before Leibniz started, and in fact worked together on a few aspects, in particular power series, as is shown in a letter to Henry Oldenburg dated 24th October 1676, where Newton remarks that Leibniz had developed a number of methods, one of which was new to him. Both Leibniz and Newton could see by this exchange of letters that the other was far along towards the calculus. Leibniz in particular mentions it, but only Leibniz was prodded thereby into publication. The actual quarrel was a retrospective affair in 1696, already some years later than the events that became the subject of the quarrel. The position still looked potentially peaceful. Newton and Leibniz had each made limited acknowledgments of each other's work, and L'Hopital's 1696 book about the calculus acknowledged Newton's published work of the 1680s as nearly all about this calculus, while expressing preference for the convenience of Leibniz's notation. At first, there was no reason to suspect Leibniz's good faith. In 1699, Nicolas Fatio de Tulier, a Swiss mathematician known for his work on zodiacal light problem, publicly accused Leibniz of plagiarizing Newton. Although he privately had accused Leibniz of plagiarism twice in 1692. It was not until the 1704 publication of an anonymous review of Newton's tract on quadrature, a review implying that Newton had borrowed the idea of the fluxional calculus from Leibniz, that any responsible mathematician doubted that Leibniz had invented the calculus independently of Newton. With respect to the review of Newton's quadrature work, all admit that there was no justification or authority for the statements made therein, which were rightly attributed to Leibniz. But the subsequent discussion led to the critical examination of the whole question, and doubts emerged. Had Leibniz derived the fundamental idea of calculus from Newton? The case against Leibniz, as it appeared to Newton's friends, was summed up in Commercium Epistolicum, I'm not sure if the pronunciation is right, of 1712, which referenced all allegations. This document was thoroughly machined by Newton. No such summary with facts, dates, and references of the case for Leibniz was issued by his friends, but Johann Bernoulli attempted to indirectly weaken the evidence by attacking the personal nature of Newton in a letter dated 7th of June 1713. When pressed for an explanation, Bernoulli most solemnly denied have written the letter. In accepting the denial, Newton added in a private letter to Bernoulli the following remark: Newton's claimed reasons for why he took part in the controversy. He said, I have never grasped at flame among foreign nations, but I am very desirous to preserve my character for honesty, which the author of that epistle, as if by the authority of a great judge, had endeavored to wrest from me. Now that I am old, I have little pleasure in mathematical studies, and I have never tried to propagate my opinions over the world, but I have rather taken care not to involve myself in disputes on account of them. Leibniz explained his silence as follows in a letter to Conti dated 9th April 1716. In order to respond point by point all the work published against me, I would have to go into much minutiae that occurred 30-40 years ago, of which I remember little. I would have to search my old letters, of which many are lost. Moreover, in most cases I did not keep a copy, and when I did, the copy is buried in the great heaps of papers, which I could sort through only with time and patience. I have enjoyed little leisure, being so weighted down of late with occupations of a totally different nature. To Newton's supporters, this was a case of Leibniz's word against a number of contrary suspicious details. His unacknowledged possession of a copy of part of one of Newton's manuscripts may be explicable, but it appears that on more than one occasion Leibniz deliberately altered or added to important documents before publishing them and falsified a date on a manuscript. All these cast doubt on his testimony. Considering Leibniz's intellectual prowess, as demonstrated by his other accomplishments, he had more than the requisite ability to invent the calculus, which he is alleged to have received was a number of suggestions rather than an account of calculus. It is possible, since he did not publish his results of 1677 until 1684, and since differential notation was his invention, that Leibniz minimized 30 years later any benefit he might have enjoyed from reading Newton's manuscript. Moreover, he may have seen the question of who originated the calculus as immaterial when set against the expressive power of his notation. In any event, and bias favoring Newton tainted the whole affair from the outset, the Royal Society, of which Isaac Newton was president at the time, set up a committee to pronounce on the priority dispute. In response to a letter it had received from Leibniz, that committee never asked Leibniz to give his version of the events. The report of the committee, finding in favor of Newton, was written and published as Commercium Epistolicum, not sure if the pronunciation is right, by Newton early in 1713, but Leibniz did not see it until the autumn of 1714. Leibniz never agreed to acknowledge Newton's priority in inventing calculus. He also tried to write his own version of the history of differential calculus, but he did not complete the matter. At the end of 1715, Leibniz accepted Johann Bernoulli's offer to organize another mathematician competition, in which different approaches had to prove their worth. This time, the problem was taken from an area later called the calculus of variations. It was required to construct a tangent line to a family of curves. A letter with the wording was written on 25th of November and transmitted to London to Newton. The problem was formulated in not very clear terms, and only later it became clear that it was required to find a general and not a particular, as Newton understood, solution. After the British side published their decision, Leibniz published his, more general, and thus formally won this competition. Whoa. For his part, Newton stubbornly sought to destroy his opponent. Not having achieved this with the report, he continued his painstaking research, spending hundreds of hours on it. His next study, entitled Observations upon the Preceding Epistle, was inspired by a letter from Leibniz to Conti in March 1716, which criticized Newton's philosophical views. No new facts were given in this document. With Leibniz's death in November 1716, the controversy gradually subsided. According to A. Rupert Hall, after 1722, this question ceased to interest Newton himself. Today, the consensus is that Leibniz and Newton independently invented and described the calculus in Europe in the 17th century. So that's all for today. Thank you so much for listening to the calculus controversy. We'll see you next week.